Thermodynamics. Thermodynamics is a very important branch of both physics and chemistry. It deals with the study of energy or the conversion of energy between different forms and the ability of energy to do work. The laws of thermodynamics describe how the energy in a system changes and whether the system can perform useful work on its surroundings. Hi, good day. Today we're gonna talk about thermodynamics on a solved problem or a sample problem about heat, and we're going to define what is heat and what is heat transfer. First, what is heat? Thermodynamics then is concerned with several properties of matter. Foremost among these is heat. Heat is energy transferred between substances or systems due to a temperature difference between them. So, what is heat transfer? Heat transfer is any or all of several kinds of phenomena considered as mechanisms that convey energy and entropy from one location to another. The specific mechanisms are usually referred to as convection, thermal radiation, and conduction. Now that we know what is heat and what is heat transfer, now let's proceed to our sample problem. So, the problem is water in a 150-liter closed, rigid tank is at 100 degrees Celsius and 90% quality. The tank is then cooled to negative 10 degrees Celsius. Calculate the heat transfer for the process. In this sample problem, we are given the following data for water. The volume is equal to 150 liters, and when converted to cubic meter, it is 0.15 cubic meter. The first temperature, or temperature 1, is equals to 100 degrees Celsius, and temperature 2 is equals to negative 10 degrees Celsius, and our x is equals to 0.9. You can see we have two different temperatures. Therefore, we have to get the different values from their respective tables. So, let's proceed to the solution. As you can see from saturated water table B1.1, you can search it in the internet, corresponding to temperature value of T is equals to 100 degrees Celsius, we can obtain specific volume and internal energy. These values are collected from the saturated water table B1.1. From those values collected, we can now calculate the initial specific volume and internal energy. This first formula is for the internal energy. U sub 1 is equals to U sub F plus X times U sub Fg is equals to 418.94 plus 0.9 multiplied to 2087.6 is equals to 2297.8 kilojoules per kilogram. The next formula is for calculating the initial specific volume. V1 is equals to V sub F plus X times Vfg, and it's equal to 0.001044 plus 0.9 times 1.6719 and is equals to 1.5057 cubic meter per kilogram. This second set of values are collected from solid saturated vapor water table B.1.5, you can also search it in the internet, corresponding to temperature value of T is equals to negative 10 degrees Celsius. We can obtain specific volume and internal energy. Our sample problem is an example of a constant volume process, meaning the volume of the water tank did not gain and also did not lose its volume. So the final specific volume is equal to initial V sub 2 is equals to V sub 1, or is equals to 1.5057 cubic meter per kilogram. So now we can calculate the final specific internal energy with this formula. But first, we must calculate the first quality factor. V sub 2 is equals to V sub F plus X sub 2 times V sub Fg. So, manipulate the formula and we get X sub 2 is equals to V sub 2 minus V sub F divided by V sub Fg, and this equals to 1.5057 minus 0.0010891 divided by 466.756. These values are collected from the water table and is equals to 0.003224. Now that we have the first quality factor, let's proceed in finding the final specific internal energy. The formula is U sub 2 is equals to U sub F plus X times U sub Fg, and this equals to negative 354.09 plus 0.003224 times 2715.5. So the answer is negative 345.34 kilojoules per kilogram. And let's remember that this is a constant volume process, so work done here is 0. Now that we are near to our final answer, we must calculate the mass. We get the formula M is equals to final volume over initial volume, and is equals to 0.15 divided by 1.5057, and is equal to 0.09962 kilograms. Now that we have the mass, let's now calculate the heat transfer. And the formula for heat transfer is Q is equals to mass times U sub 2 minus U sub 1. U sub 2 and U sub 1 are the specific internal energy, and is equals to 0.09962 times negative 345.34 minus 2297.8, and our final answer is Q is equals to negative 263.3 kilojoules. So that's it for this video. Thanks for watching.